Welcome to section 4.2.3. We're going to be talking about, in this part, graphing absolute value functions. Now, we've talked about transforming with A, H, and K. A is that stretch, compression, reflection. H is shifting left and right, and K is shifting up and down. Now, there's an easy way to graph absolute value functions without transforming and without even using a calculator. Now, to do this, we need our vertex. And the vertex is at H and K. Then A acts as a double slope. It's going to be our rise, and then we're going to run in both directions. Double slope is an unofficial term that I'm making up, but it works like that. If you say that I mentioned this word, I will ignore its existence. It's just a way to help us think about it. So what we're going to do is for number 1, A is -2. H is 1 and K is 3. So our vertex is at 1, 3. So what we do is we plot the vertex. We go over 1 and up 3. Now, these absolute value functions are going to be V-shaped. If A is positive, it's opening up. If A is negative, it opens down. So A is -2. So that means what we're going to do is we're going to go down 2 and to the left 1. And we can also go down 2 and to the right 1 and keep doing that. And what that's going to do is that's going to give us our V-shaped graph. And there is our absolute value function. Now, because we want to keep it fresh, our domain and range. Domain, it's all real numbers. Our range, y is less than or equal to 3. Number 2, A is 1. H is 2 and K is 5. So our vertex here is at 2, 5. So we plot the point over 2, up 5. And now A is 1. We go up 1 and to the right 1, up 1 and to the left 1. And just keep going and give us our V-shaped graph. Our domain, all real numbers, and our range, y is greater than or equal to 5. I think this is just a really quick way to graph these absolute value functions. For number 3, A is -1/4, H is 0, K is 0. So our vertex here is at 0, 0. So A is -1/4. We go down 1 over 4 in both directions. And just keep going down 1 over 4. And there is our graph. Our domain, all real numbers, and our range, y is less than or equal to 0. Number 4, A is 1, H is -4, and K is -3. So our vertex is at -4, -3. And then A is 1, so we're going to go up 1 to the left, up 1 and to the right, and we just keep adding points up 1 over 1 in both directions. Our domain, all real numbers, and our range, y is greater than or equal to -3. And there's our graph. On the next page, we're going to be talking about writing the equations of the graph. So really what we need, they're in the form of y equals A, absolute value, H x minus h, and then plus k. So we need to find our values for a, h, and k. A, h, and k. So the vertex is h and k. So we're going to the left 1 and up 2. So h is a negative 1, k is a positive 2. And then for a, what we can do is from that vertex, we can look and count to the next point. We go up 1 and over 1. Since it's opening up, it's a positive, so a is a positive 1. So y equals, a is a, absolute value of x minus h plus k. So y equals a, which is 1, times the absolute value of x minus negative 1 plus 2. So we rewrite y equals absolute value of x plus 1 plus 2. For number 6, a, h, and k. So our vertex, we're going to the right 2 and up 3. So it's going to be 2 and 3 for h and k. And a, if you look, to go from here, the vertex, into the next point that we can easily read, we're going down 2 and to the right 1. So we're going down 2 over 1, so a is a negative 2. So y equals negative 2, absolute value of x minus 2 plus 3. And there is our absolute value function. Number 7, a, h, and k. So from the origin, we're going to the left 2 and down 3. So h is a negative 2, k is a negative 3. Now for a, go from the vertex and count up and over to get to the next nice grid point like that. So we go up 1, over 2. So a is 1/2. So y equals 1/2, absolute value of x minus negative 2 minus 3. So y equals 1/2, absolute value of x plus 2 minus 3. And there is our absolute value function. Okay, thank you. And I will see you in the next video where we talk about solving these absolute value functions.